Okay, so imagine this. We're talking about taking CO2, the gas we're always trying to reduce,
Yeah.
and like turning it into something we can actually use, like valuable building materials.
Right.
Not just any materials, though. We're talking super strong carbon composites.
Yeah.
The kind they use in everything from cars to planes.
Exactly.
So today's deep dive is all about this fascinating new process.
Yeah.
We found this article in Nature Communications, and it lays out how scientists are doing this seemingly magical transformation.
Yeah, it really is like a whole new way of looking at things, turning CO2 into a building block instead of like a waste product.
Right.
It's key to a sustainable future, I think.
Okay, so we all know rising CO2 levels are a huge problem.
For sure.
But what's so different about this approach?
Wow.
I mean, people are already working on capturing carbon, right?
Yeah, they are. But the thing is, current methods can be really expensive and energy intensive. But what's unique here is they've actually found a way to convert that captured CO2 into solid carbon. And that's a big deal for a lot of reasons.
So what's so special about solid carbon then?
Well, first off, it's so much easier to store and transport
Right.
than gas. It's safer, too. Plus, we can use it directly to create those valuable materials, like the carbon nanocomposites we were talking about.
So instead of just trapping it underground,
Yeah.
we're actually turning it into something useful.
Yeah.
I like that. Tell me more about these carbon nanocomposites, though.
So basically, they're made up of these tiny tubes of carbon atoms
Okay.
arranged in these really unique configurations, and these structures make them incredibly strong and light.
Yeah?
Actually, they're already being used to revolutionize industries like aerospace and automotive because they can make vehicles lighter
Oh, yeah.
and more fuel efficient.
I can see how that would be a big deal. But those composites usually come from fossil fuels, right?
Exactly, which kind of defeats the purpose.
Yeah.
So that's where this new process comes in.
Okay.
It gives us a way to make these high-performance composites, but using CO2 as the starting material.
A green alternative, basically.
Exactly.
All right, I'm hooked. Walk me through how it all works.
Okay, so it's actually a pretty straightforward two-step process. First, they use electrochemistry to convert that CO2 into carbon monoxide.
Okay.
And get this, they do it at room temperature.
Wait a minute. Room temperature? That sounds way too easy. Usually these kinds of transformations need a ton of energy and heat.
Right, and that's part of what makes this so innovative.
Ah.
By working at room temperature, they can cut down on the energy needed.
And the cost, I bet.
Big time.
Clever. So what happens in step 2 then?
So in step 2, they take that carbon monoxide and react it with hydrogen
Okay.
at a moderate temperature. But here's where it gets really interesting. They use steel wool as a catalyst to speed up the reaction.
Hold on. Steel wool, like the stuff I use to clean my pans.
That's the one.
Wow.
And it turns out steel wool is surprisingly effective at this. It's even better than more expensive materials like nickel or stainless steel.
So they're using a common, cheap material to create high-tech composites from CO2.
It's pretty amazing.
I'm impressed already.
Yeah.
So what's the end product of all this steel wool magic?
Carbon nanotubes. The strong, unique ones we were talking about.
Oh, wow.
And here's another cool thing. The byproduct of this second step is more CO2.
So they can recycle that CO2 right back into the first step.
Exactly. It's a closed-loop system.
Brilliant. So are we ready to get into what they actually did with these nanotubes?
Definitely. That's where things really get exciting.
Okay, let's do it.
All right, so they use them for some amazing 3D printing stuff.
Ooh, 3D printing. Okay, I'm ready.
That's what we'll get into next.
Okay, so we've got these carbon nanotubes made from CO2.
Right.
And now we're going to bring in 3D printing. I'm guessing this is where things start to get really futuristic.
3D printing is really key here.
Okay.
It lets you create all these complex shapes and structures. You can
Okay.
really control the properties of the material that way.
So what kind of stuff did they actually make with these nanotubes and this 3D printing? I mean, did they print a car?
Well,
A house?
not quite a car or a house,
Oh.
but what they did is still pretty amazing.
Okay.
They developed this technique for 3D printing using a special filament
Okay.
made of plastic mixed with the carbon nanotubes.
So they're basically printing with plastic, but it's reinforced with these super strong nanotubes.
Exactly. What happens next?
So after they print the structure, they heat it up, which burns away all the plastic.
So all that's left is the carbon.
You got it. You're left with this really strong and intricate carbon skeleton.
Wow, that's amazing. It's like a delicate carbon scaffold. But is that the final product?
Not quite. They then infuse this scaffold with epoxy.
Okay.
It's a kind of resin
Uh-huh.
to make it even stronger and create this solid composite material.
So they're basically combining the strength of the carbon nanotubes with the bonding power of epoxy. I bet that makes a pretty strong material.
Yeah, you're right. It turns out this 3D printed carbon nanocomposite was way stiffer than epoxy alone.
How much stiffer are we talking?
It had a 68% higher Young's modulus. Okay, so back up a second. What exactly is Young's modulus and why should I care if it's higher?
Well, think of Young's modulus as like a measure of stiffness or resistance to bending. So the higher the modulus, the stiffer the material.
Got it.
And in this case, their composite material is way more rigid than just epoxy.
So it can handle a lot more weight.
Exactly.
Okay, so to recap, we've got building materials that are lightweight, strong, and made from recycled CO2. It almost sounds too good to be true. What other cool properties did they find?
It gets even better. The way those carbon nanotubes are aligned within the printed structure also makes the material much better at conducting heat and electricity.
Wow. So it's strong, stiff, and a good conductor.
Right.
This material really does it all. Where could we even use something like that?
The possibilities are endless, but construction is a big one.
Yeah, I can see that.
Imagine buildings that are lighter, stronger, and more energy efficient.
Right.
And they're made with material that's actually removing CO2 from the atmosphere.
That's a pretty incredible vision for the future of sustainable building. Are there any other industries where this technology could be a game changer?
Absolutely. Think about cars. Lighter, stronger materials could mean more fuel-efficient vehicles.
Right.
And we already talked about how carbon composites are being used in that industry.
Yeah.
This new process could make them even more sustainable and affordable.
Okay, so we've talked about strength, conductivity, and sustainability. But let's be real here. Cost is a big factor in whether these kinds of innovations actually take off. How does the cost of this process compare to the traditional ways of making carbon nanotubes?
That's the best part. This new method could produce carbon nanotubes for a fraction of the cost.
Really?
We're talking about bringing the cost down from around $100 per kilogram to just $9.50 per kilogram.
Wow, that's a huge difference. That could really change the whole market and make these materials available to way more industries.
Exactly. This cost advantage is huge, and it's even more significant when you consider how big this market could be.
Okay, let's talk market potential.
Yeah.
Then how big could this get?
Well, the carbon composite market is already worth billions of dollars.
Yeah.
And it's only going to grow. It could be worth trillions of dollars by 2050.
Trillions. That's insane. But I'm guessing a lot of that depends on getting the cost down.
You got it. And that's where this new CO2-based method comes in.
It's kind of like we're turning a climate change villain into a valuable resource.
This really is a whole new perspective. And it shows how scientific innovation can help us solve these big challenges.
Of course, with any new technology, there are always some things to consider.
For sure.
What are some of the challenges they'll have to overcome to make this technology work on a large scale?
One of the biggest challenges is going to be scaling up production. I mean, we've seen some really promising results in the lab.
Yeah.
But actually producing this stuff on an industrial scale,
Right.
that's a whole other story.
I can imagine. What are some of the hurdles they're going to have to overcome?
Well, first, they're going to need to figure out how to make those carbon nanotubes in way bigger quantities.
Yeah.
But they'll have to do it without sacrificing quality.
So it's not just about making more, it's about making sure it's good quality too.
Yeah, exactly. And then there's always the money issue.
Right.
Even though it's cheaper than traditional methods, it still has to be able to compete with the materials we're already using, like steel and aluminum.
Yeah, that's a good point.
Yeah.
Even if it's more sustainable, it won't get used if it's too expensive.
Exactly. But I'm optimistic about it.
Right.
As they make more and more of this stuff and the technology gets better, I think the price will keep going down.
That makes sense.
Yeah.
We should also think about the environmental impact too.
Yeah.
I mean, beyond just capturing the CO2,
Yeah.
what about all the energy they use in the process?
Right.
Or any waste they create?
Those are really important things to think about.
Yeah.
The process itself is pretty energy efficient, especially that first step at room temperature.
Right.
But you can always make things better.
Uh-huh.
They're looking at ways to use renewable energy and optimize the process to use even less energy.
That's great. It sounds like they're really thinking about the whole picture when it comes to sustainability.
Yeah, they are. And as for waste, that closed loop system where they recycle the CO2 is a big step in the right direction.
It definitely is.
Uh-huh.
So it sounds like there are some challenges.
For sure.
But there's also a ton of potential for this technology to get even more sustainable.
Yeah, I think so.
What are you most excited about?
Well, I think the coolest thing is that we might be able to completely change how we think about carbon. Instead of thinking of it as just a waste product, we can start seeing it as this valuable resource, something we can use to build a more sustainable future.
It's like flipping the whole story on its head. CO2 goes from being the bad guy to being the hero.
Exactly. And I think that could inspire so much innovation as we find new ways to use carbon.
This whole deep dive has been mind-blowing. I don't think I'll ever look at CO2 the same way again. What's the one thing you hope our listeners take away from all this?
I think the main takeaway is that even with all the problems we're facing with climate change, there's still so much hope and so many brilliant people working on solutions.
Right.
This research is a perfect example of that.
Absolutely. Well said. And remember, listeners, innovation is happening everywhere. Keep learning, stay curious. And who knows, maybe one day you'll be living in a house built with CO2-derived composites, breathing a little easier knowing we're on the right track.